Okay, we're gonna skip all the things going with limits. So that won't be on the test. Let's go to number 2.
Are you learning about the limits of eventually?
I'm sorry.
Are you to learn about the limits then?
Not this time. Yeah, it's not gonna be highlighted on the exam. At least not this time. Okay, so number 2. Number 2 is Rolle's theorem. Number 3 is mean value theorem. They're basically the same formula. So let me just kind of review what we're going to be working towards. Mean value theorem or Rolle's basically follows this formula. We have to basically look for the derivative, but before we do that, we want to figure out the slope between the endpoints. So we need to find order pairs, right? So we'll do this portion first before the derivative, and then we'll find the derivative second, and then next we'll just set them equal to each other. So that's really the only difference with Rolle's theorem is that f of a and f of b will end up being the same value, which will force this slope to be 0. But mean value theorem, this slope can be any number, including 0. But chances are, if it's mean value theorem, it will probably be a different number. But Rolle's theorem, it has to be 0. Now, basically, mean value theorem and Rolle's theorem is trying to guarantee a slope. And anything that's slope related, we have to first ensure that the graph is continuous and differentiable. So the ones I give you will be. So you just have to be able to state that to be true. So our function, it says determine whether Rolle's theorem can be applied. Okay. Secant does have vertical asymptotes, but it will be continuous on this closed interval. So let's just practice writing out our, because our continuity conditions are indifferent and slope conditions. So our function is continuous on the closed interval. Closed interval just means with brackets. And then differentiable the open interval. With parentheses. Okay, Rolle's theorem and mean value theorem, we have to just go through and find the order pairs before we can find the slope. So no calculus yet. We're just going to find what's happening at these endpoints. So we'll do secant of negative pi over 4 and then secant of pi over 4. Now, if you don't recognize negative pi over 4, what can we do to make it more familiar to us? Add 2 pi, right? So what's negative pi over 4 plus 2 pi? 7 pi over 4, right? Secant of 7 pi over 4. If you're not familiar with secant of 7 pi over 4, it's okay. Let's think about cosine of 7 pi over 4. What's cosine of 7 pi over 4? Root 2 over 2. That's cosine. If cosine is root 2 over 2, then what's secant going to be? Yeah, 2 over root 2, which you can leave it like that, or it's the same thing as root 2. All right. The other endpoint that we need to find location of is secant of pi over 4. Again, let's think in terms of cosine. What's cosine of pi over 4? Root 2 over 2, which means secant of pi over 4 will be the reciprocal, which is 2 over root 2, which is also root 2. All right, so now let's find the slope between the endpoints. What's the slope going to be? I'm going to call this the average rate of change here. Change in y over change in x, what do we get? 0, yep. And will this fulfill the conditions for Rolle's theorem? Yes, right. Rolle's theorem requires the slope to be 0. Mean value theorem, it can be any slope, but we know our slope is 0. So now we're going to set our derivative equal to 0. Okay, so the algebra portion is done. Let's move on to the derivative, the calculus portion. So now let's find the derivative of secant. What's secant's derivative? Secant x tangent x. Now we're going to set this equal to 0. Maybe it's a little bit easier to think in terms of sine and cosine than in terms of secant and tangent, and also allows us to merge things a little bit better here. So before I set f prime equal to 0, I want to kind of play with f prime a little bit. What's another way to represent secant? Secant is the same thing as what? 1 over cosine. Tangent is the same thing as sine over cosine. So my f prime is just basically sine over cosine squared x. So this is what we're setting equal to each other. We want to figure out where is my slope equal to 0. Now, whenever I set a fractional value equal to 0, or a fractional expression equal to 0, where am I looking? Am I looking at the numerator? Am I looking at the denominator? Am I looking at both? Just the numerator, right? The reason why is because we want to figure out whether slope is 0. If we set the denominator equal to 0, then we're asking where the slope is undefined, right? And the slope is undefined. That's not part of Rolle's theorem. So really, we're just focused on the numerator part. That's the only part that we care for. Now, another way to think about this is if you put this over 1, and if you cross multiply, the cosine goes away. I'm still left with sine of x equal to 0. So let's think about sine of x. And where is sine equal to 0? Pi and 0 and 2 pi. Right. Now we want to find something that was within the interval here. None of this is within the interval, so what can we do? Actually, we do have something. Sorry, we do have something in between the interval, which is what? 0. Yeah, so 0 is safe. Everything else, if we try to subtract 2 pi, we're going to still be outside the interval. So that's our c value. Our c value is 0. Okay, so that's Rolle's theorem, which is basically mean value theorem. Let's do another example. This one is mean value theorem, and all that's different here is that the average rate of change does not have to be 0. That's the only. It's less restrictive than Rolle's theorem, but same process. We're still finding endpoints. We're still finding slope. We're still finding derivative. We're still setting them equal to each other. Okay. All right, so f of x equals 2 sine x plus sine 2x. This is a nice curve function, no asymptotes, no holes, no sharp turns. So our conditions will pass. Let's go ahead and practice writing out our conditions. Go on a separate sheet.
The function you give us will always be continuous in differential.
That's right, yeah, so,
So we don't have to worry about it not being.
right, so you just have to worry about writing out the conditions. Sorry, parentheses. So continuous is with brackets, differentiable is with parentheses. Okay, so again, here's our formula for mean value theorem. Okay, do this portion first, and then do the second, and then you can set them equal to each other. Okay, so first things first, let's find the order pairs. So we can build the slope out of it. Right, f of 0 equals 0. Two sine pi plus sine of 2 pi equals what's sine of pi? 0 plus sine of 2 pi. 0. So looks like this could, I mean, if we wanted to call this a Rolle's theorem, we could, but it doesn't have to be slope 0, but it ends up looks like it is, because if I find the average rate of change, I get 0 minus 0 over pi minus 0, which is equal to 0. But it doesn't have to be 0, right? Now, Rolle's theorem would have to be slope 0. Now, Rolle's theorem doesn't always mean that it's always equal to 0. It means that it's always equal to each other, right? So previous example is root 2 and root 2. Here is 0 and 0. So, a mistake that I see students make with Rolle's theorem is I see students, they see the root 2 and root 2, and then they would set the derivative equal to root 2, right? But we don't want to do that. We always want to make sure that we take the time to find the slope between the endpoints and set the derivative equal to the slope. Don't set the derivative equal to whatever these numbers are. Now, it just so happens that this ends up being the same number as this, but it's a different process, right? This is 0, but really what we're after is the slope between the endpoints, which happens to also be 0. Okay, next up, let's find our derivative. All right, we have our slope. Now let's find our derivative. All right, 2 sine x becomes 2 cosine x. All right, sine of 2x becomes what? Good. So a little bit of chain rule here. Cosine of u times u prime.
2x is u value.
That's right. 2x is u value. Good. Okay, what's next? Yeah, set our derivative equal to the slope between the endpoints. Okay. Now, cosine of 2x here, we're not going to be able to do inverse with that cosine in the way. We're going to have to rely on special cosine properties. So the double angle identities, if I so I'm not gonna ask you to memorize the identities. If this shows up, I'll provide it for you so you can use it. So cosine of 2x is the same thing as 2 cosine squared x minus 1. Okay, so we can make that substitution to get it out of double angle so they can have an easier time working with this equation. All right, any questions here? Do we see the substitution that we made here?
Was that like one of the identities?
Yeah, this is an identity here, yeah, which I'll give you if it shows up on the test.
It looks like the one we did in pre-calc.
It is, yeah, exactly, yeah, it is a pre-calc topic. Okay, so let's clean this up here. This is a trinomial factoring problem here. Let's organize it with in descending degree. I can factor a 2 out. So if you don't want to factor in terms of cosine, maybe we can step away and do an easier version of the problem. What if I ask you, what's the factored form of 2x squared plus 2x minus 1? Multiplies to be -2, adds up to be 2. Oh, I'm sorry, not 2. My bad. That's a 1 here. Okay, multiplies to be -2, adds up to be 1. Okay, so now that we have something in factored form, let's bring back our cosine, which is really the variable that we're working with. So okay, set equal to 0. We can set both parts equal to 0. The 2 equal to 0 is not gonna, there's no variable here, so we can ignore that. It's just the 2 cosine x minus 1 equal to 0. And then the cosine of x plus 1 equal to 0. Okay. Cosine of x equals to 1/2. Cosine of x equals -1. Okay, so let's think about unit circle values here. Where's cosine equal to 1/2? And 5/3, yeah. All right, where's cosine equal to -1? Pi, okay. Now, let's go back to our interval here. Our interval is, we're looking at what's between 0 and pi. There's guaranteed at least one solution, but if there's more than one, we got to make sure that they all fall inside the interval. Do any of these work? 5/3. Now, let me ask you this, does pi work? It doesn't. Okay, so with mean value theorem and Rolle's theorem, we have to look for a c-value that's between the endpoints. If it lands at the endpoint, it's not good enough. So these, well, we do have one solution, which is what? pi/3. Yeah, pi/3 lands between, and if we got this far, we're guaranteed at least one solution. We won't have a no solution with mean value theorem and Rolle's theorem. Okay, you're guaranteed at least one.
This would always be one solution.
Yes. Well, it's one or more. But if there's more, you have to make sure that they all fall inside the interval. So you're guaranteed at least one, but it could be more than one. Okay, number two, it looks like, sorry, no, number two, back, page two. Page two, it says position, average velocity. It looks like particle motion problem, but really this is a application of mean value theorem. Let me save this for us to try, because we have 2 more days here. Let me save this for us to try a little bit later. Let me go to another topic for us to work on. Let's do a related rates problem. Really want to focus on this one here, number 5. So you'll see a problem similar to number 5 in terms of page 4, in terms of how it's set up. Okay, so if you feel good about this related rates problem, then you should feel good about the test question you're going to see. So it'll be a problem like this where part A is dealing with Pythagorean theorem, and then part B is dealing with d theta dt. Okay, so we have person X and person Y walking on straight streets that meet at right angles. Y travels south, and then X travels east and moves away from the intersection. So let me draw the
Related rates.
yeah, this is related rates. Yeah, anytime that you see a word problem with time involvement, it's always going to be related rates. Okay, so I'm going to call this XYZ here. Find the rate at which the distance z between person X and Y are changing. So we know Pythagorean theorem. We're going to find the derivative, get all 6 variables accounted for. So part A should just be familiar problem that we've seen in the past. Derivative, d over dt will show up. Okay, let's list out all the variables that are involved. Okay, let's go back to our problem here. Y travels south and approaches the intersection at 2 meters per second. What is that referring to? Okay, anything special about d by dt? Negative because decreasing, not because it's going south, right? The south has nothing to do with this. The fact that this length of your triangle is getting shorter because as it moves closer towards the intersection, this is going to get smaller, right? So -2. Person X travels east and moves away from the intersection at 1 meters per second. What's that? Dx over dt. And positive because increasing, not because he's moving to the right. And moving to the right could sometimes mean decreasing, but it really depends on what you see with the dimension, right? Is the dimension changing? Is it increasing or decreasing? If it's increasing, you want that rate to be positive. Okay, find the rate at which the distance z is between person X and person Y is changing. What are we looking for? Sorry, I said dy dt here, dc dt. Yeah. That's the unknown. when y is 10 meters and x is 20 meters. Okay. How can we find z? Pythagorean theorem, okay. A squared plus b squared equals c squared. Do root 500, or you can say 10 root 5, either way. Okay, let's fill everything in and solve for dz dt. Now, I want to make sure that we understand this is not like the ladder problem where dz dt is always 0. It just so happens that because at this moment in time, that rate of change is 0. But if we pick up at any other time, dz dt is going to be either shrinking or increasing, right? So this is just a specific, just a coincidence that it's just for this moment in time, dz dt is changing, probably because it was increasing and all of a sudden it's about to decrease. So there's that interchange where it's going to experience a 0 meters per second. But typically we can expect this, especially with all three sides changing, we can expect dz dt to be a non-zero value usually.
Could happen where it's 0.
Huh?
It's possible where the value is 0.
It's possible it's 0, but chances of it is going to be slim of a problem with all three sides changing. Okay, part B. At what rate is the angle theta changing at the same moment? So now, technically, we can choose any of the three variables to test to use, either sine, cosine, or tangent, because we have all the available information. But I would like, especially with all three sides changing, I know that maybe you want to take advantage of z because there's a dz dt being 0. But for practice purposes here, let's say we're going to use tangent. The reason why I want to use tangent here is because that's the original information that's provided. Information provided in terms of x and y. It's not wrong if you want to involve a variable that has a missing component that you just found. But just for future purposes, I think it's good to rely on the original information provided. Because if this was wrong, then that will kind of snowball into the answer of your next next process. So I like to rely on the originals, just so that it kind of gives me a fresh start, and also for us to kind of practice what I want us to practice. Okay, so Again, technically, we could use any of the trig functions. I'm going to use what is provided for us. And also, technically, there's not a way around quotient rule because there is no constant in this diagram, right? X is changing, Z is changing, Y is changing. So tangent of theta equals what? Y over X. Okay. Tangent theta becomes and to the right side, we have to rely on what rule here? Quotient rule. Okay. Okay, what's Y's derivative? dy over dt, yeah. Everything is going to get impacted by time times. Yeah. Let me label here. Okay, back to F minus. What's F? Y. G prime dx over dt all over x squared. So technically, we have everything available for us to use, right? We have dy dt, we have x, we have y, we have dx dt, we have x squared. We're looking for d theta dt. So, and then what's the last piece of the puzzle that we have to focus on finding? Okay, not theta. We want to find what? Secant of theta. We want to find secant of theta, and then we can square that resulting. Okay. So let's go to the side and figure out what secant of theta is. Once we do that, then we can put everything in and we can go through our calculations. So I'm going to draw another triangle here and focus on filling out the sides of my triangle for this moment in time. Okay. What's the base going to be at this moment in time? X is 20. Y is 10. Hypotenuse is 10 root 5 or root 500, either one. Okay, so we gotta do this work, right? Secant of theta. What's secant of theta here? Yeah, this is going to be root 500 over 20, or 10 root 5 over 20 is going to be hypotenuse over adjacent. You know, it's the reciprocal of cosine. Okay. And that reduces to be what? Root 5 over 2, right? Because 10 and 20 can reduce. All right, so now I'm ready to put everything in. I have numeric values that can replace everything I'm going to be working with. Everybody okay so far? Yeah. Huh? We do, yeah. So I'll do that once I put that in here. But yes, you're right. We gotta square that. Okay, I'm just gonna put everything in from part A that we've gathered. dy dt is -2, x is 20, y is 10, dx dt is 1, and x is 20. We gotta square that. Okay, this becomes 5/4. I'm going to divide by that fraction, which is the same thing as multiplying by the reciprocal. I'm going to flip that over to the right side. This is -40 minus 10, so that's -50. Use your calculator. Okay, what's our unit of measure here? Radians. Have you sit in the back there? Okay, let me just walk through the process again here for this problem. Part A, hopefully that feels very familiar with Pythagorean theorem. Part B, if we can rely on a side length that is a constant, we would. But here all three sides are changing, but we want to target tangent because y and x is what is provided for us in full. So that's why it's just nice to start with everything that is provided for us. So we start with tangent. So tangent theta equals y/x because of the variables here. We can't just do power rule. We are forced into quotient rule here. So we go f prime g minus f g prime all over g squared. Remember that every time you find the derivative of a variable, a bunch of d over dt's will show up because we're doing related rates. D theta dt shows up. That's the variable that we're looking for. Everything on the right here should be ready for us to plug in because we've gathered all that from part A. What's new about trig derivatives, trig relay rates is having to go through this second set of substitution. Okay, remember, we're not going to know what theta is, and that's not our focus. Our focus is to replace the entire trig function. Okay, so we have to go and create a second triangle, draw that triangle, fill out all three sides, and then find the ratio. Once you find that ratio, make that substitution, and now you're down to just a bunch of numeric values that you can use your calculator to get it down to an answer. Yes. Oh, you mean at the beginning? The reason why is because this is just a moment in time. The ratio and the length will not be 10/20 for the entirety of the problem, right? These people, they keep walking, right? So we're just trying to find out this moment in time. So if we just put tangent theta equals 10/20, then we lose the ability to find d theta dt because the derivative will be 0. So yeah, it's not a true relationship if we don't include the y and the x. Okay, we have to include the y and x because these values are changing. Now, if these people are just standing still, if they're not moving, then yes, then we can say 10/20 and that's fine. All right. But if there's movement involved, we have to use a variable to account for the fact that at any moment in time, that distance is not going to be the same.
Probably just some cuts.
Yeah.
Then the mean value theorem problems.
Mean value theorem.
And rows.
Or rolls. Yeah, mean value
One of
theorem.
the
Rolls. Yeah. Yeah, so if you look on the board here, these are, again, the topics that you can expect to see. It'll be 6 problems, but then the related rates, the mean value theorem, and trig will be extended problems. And then you'll have 1 inverse trig derivative and 1 implicit differentiation with trig, similar to what you guys did on the quiz.
Could there be like a shadow problem? Because I know it's like retroactive or not.
It'll be basically this problem. Okay. If you know how to do this, you should feel good for, I think, no surprises here. Okay. Okay. Again, the trouble that students have with this problem is, or with these class problems is students get stuck wanting to find theta. That just throws everything off. So just keep reminding yourself, you're not trying to find theta. You're trying to find that trig ratio. So you got to do that second triangle, and that second triangle will help you find that ratio, and you can make that your substitution.
Just 2 formulas to know for part 1.
No, that, sorry, the natural log of u and e to the u, those are just good rules for us to make sure that we still know. That's not attached to number 6.
We could see it on the test. So.
Possibly, yeah. So I want to make sure that we remember to use how to apply those rules, or well, basically remember those terrific rules.
And you said like if we had one like do you ever wonder there's like a trend any, would you give that to us?
Yeah, that's right. I'll give you. Yeah. Okay, so tomorrow we'll do page 2. There's more of the mean value theorem and rules. Maybe we can do another related rates, another curve sketching. So we'll have 2 more days to kind of run through these types of problems. Yeah, tell me your points. Yeah, so cosecant is related to time, right? Let's think about what sine is. Yeah, realize that, right? So that.
I don't want to worry about the older.
Sorry. So cotangents, we know that that's probably, one for one.
Like the brain.
Like great. Yeah.
Thank you so much. I guess you can need to talk. Great. It's going on. Is that good? I mean, it's not work. We're just still on it. Like they're long. You'll see like the local dates like over to one problem.
So you put 5 or 3 in.
I was California. No, I haven't.
So
Our South.
5 or 3 should be.
Yeah.
That's good. That's good.
I'm like wondering how to do those, like what problems, like I can highlight for the middle of the. I see you're good.
No one. And then change.
Yeah. But this really just kind of application of these on theorem. Having to find the equations, but if you can find the derivatives, that's good.
Yeah, that's.
Not that bad.
Yeah, find the derivative.
It's like. Of the fan,
You have to find the equation of tangent line, but you know how to find the derivative.
but it's still this.
And then, yeah, so all these have to be able to find the derivative. You have to go as far as the. Yeah, if you can do that, you can be ready.
Alright.
Yeah, and then make sure you memorize your rules. And then you feel with the quiz topics, you can't go with that. So, yeah.
So you don't really need to come in next Friday, but we just on Friday.
Appreciate it, thank you.
It was all right. It was pretty good. How about yours? Good, pretty well. Last year? I haven't experienced it. Okay, so you'll see our video then. Because videos are.
The chair.
We need like a rendition of like that way. But.
She texted us.
Okay.